Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel Chaiken. We are here to help you figure out how to approach SAT math questions. Here's an SAT math question, number 7. So your brain hasn't been fried yet, and it is in the non-calculator section. Okay, so I'm just getting ready here. Good. Okay, so obviously this is a word problem with some numbers. Something tells me there's a rate involved in this, but we'll see. When preparing to run a marathon, Amelia created you should do it yourself and, of course, pause the video and then come back after you've done it. When preparing to run a marathon, Amelia created a training schedule in which the distance of her longest run every week is increased by a constant amount. Ooh, slow, great. If y equals mx plus b, I see it already. Maybe. We'll see. If Amelia's training schedule requires that her longest run in week 4 is a distance of 8 miles, and her longest run in week 6 is a distance of 26 miles, which of the following best describes how the distance Amelia run changes between week 4 and week 16 of her training schedule? So this is just the slope of between 2 points. Right, Seth? Is that yes or no?
I don't like. I think so.
Okay, good. So let's do the slope between 2 points. I say 30% of the time I mess this up because I always get confused. I always mess it up. So let's see. 20. So I'm going to be very careful. Why? Because I know personally that I mess this up a lot. So I'm being extra careful because I don't want to get this wrong. I'll do the bottom one first. That's easier. Non-calculator test. Oh, what is that? Oh my God, what is that? Is that? Wait, I'm struggling here. 6.
18.
6. Seth, don't tell me the answer. I have to struggle. 26 minus 8, yeah, is 18. Okay, 18. So that we have to simplify that, right? But let's see. Is 18 over 12? Not really an answer. So let's simplify that. Let's divide by 6. So we get 3 over 2. Oh, I see a 1.5 there. Let's read. Now we read the question. Now we read the answers. Amelia increases by a half mile each week. No. 2. No. What is this? 2 miles every 3 weeks? Well, that's 2/3. Oh, that's the reciprocal of the answer. Amelia increases over the longest run by 1.5 miles each week. Aha. That's the slope. So I think that's the answer. So, now what do you think?
That looks good to me.
Would you have?
Yeah.
I mean, of course, when you do the problem, I'm looking at the timer, I spent about 2 minutes and 15 seconds on this. You probably, in real life, when you take the test, you do it faster.
Yeah.
But do you notice, I don't know, it's debatable whether what I did here is a good thing to do, to start doing the problem and start thinking about how to do it before you even read the answers. I don't know. It's tempting, right? It's tempting.
Could be, yeah.
It's tempting, as opposed to reading the question entirely, digesting it, and then figuring it out. I don't know.
Yeah.
And everybody has their own method of solving it. Just I want to try to do it as fast as possible. But does everyone see how this is the slope? You can, this is. So you want to. I didn't really describe it very well as to why that's the slope, why that's the rate.
Well, it's it's rates. It's you might not even, but you could even avoid thinking of it in terms of slope and just thinking of it as a problem in arithmetic. She increases her distance from 8 to 26.
Right.
And so the increase is 26 minus 8, which is 18.
Right. Good.
And the number of weeks in which she does it is the difference between week 16 and week 4, which is 12.
Right.
So the longest run, the distance of the longest run increases by 18 during 12 weeks. And then you keep dividing that to see how much she increases the distance in 1 week.
Right. Yeah.
of
Yeah.
how much he increases the distance in 3 weeks and how much he increases the distance in a week and a half.
Yeah.
But
Yeah.
getting the answer in simplest terms of three halves, then it could be used to check to test, each of the
yeah. But nobody's going to have
each
time
of
to do
the
that.
rates of increase.
Right.
Notice that the rates of increase are expressed in 3 different ways with 4 different choices. This is per week, the amount per week, and then what's going on, and then this one is per 3 weeks.
Yeah. Right.
And this is also per week. So this is per 3 weeks.
Yeah.
Yeah.
The units certainly help you here.
This is per 3. Something like my cursor is kind of weird. All right, that's
yeah. And then the units really help you here. The units absolutely help you because see, it's miles per week, so the units have to be miles per week. So these are miles. The units of this thing are miles. The units of this thing are miles, and the units of this thing are weeks. And notice that we're doing miles per week. So that the units really help in rate problems and proportion problems, all these y equals mx plus b problems, linear functions, so when something changes by a constant amount. This is where all of our intuition lies, because in our lives, a lot of things in our lives change by a constant amount. Otherwise, we'd go crazy.
Change by a constant amount in a given period of time.
Yeah, and given a period of time, right?
And so to understand a rate of change, you need to know how much the change is, together with how much the period of time over which that change is.
Right. That's right.
Yeah.
Okay. I guess we're done.
Yeah, done.
Okay. So have a great day. Please give us comments, like us, dislike us, but most importantly, give us comments and send your SAT math questions to satmathquestionoftheday@gmail.com. Okay, everyone. Have a great day. Bye.
Hey, have a good day.
Bye.